This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 9 problems from the November 2025 Digital SAT Math Test. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Before I begin going through this first November 2025 Digital SAT Math official test problem set, I want to mention a couple things that I talk about at the start of all these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there will be a link to the PDF file that has all these problems in it, both in the description of the video and also in the pinned comment of the video. Third, be sure to check out basically video and worksheet number 2 once that is posted, and also video and worksheet number 3 is basically going to be a summary of the repeat problems that I have already covered in previous videos, but that were reported to have appeared on the November exam. So it's not going to be an in-depth work through of all the problems on there. Basically, that worksheet has 20 total problems. It's just going to be briefly highlighting the problem, and then the worksheet for it will have the other months and year and worksheet and problem number where that problem was already basically worked out in detail. Another thing just to mention as well is hopefully you saw one of my recent videos where I talked about a spreadsheet both in Excel format and also in a PDF file, which has all of these problems from my official test playlist worksheets. So you can sort, you can filter by topic, and it also has brief descriptions of the problem and everything. So this way, if you see a specific type of problem, then you can go and search. It's the spreadsheet currently has 350 some problems in it. But once we add in the 9 from this and then the 9 from video number 2, it'll be up over, I think, 370 total problems. And you can see if there are similar or identical problems that I've already covered in other months, okay? And it'll tell you exactly, 2024, December, worksheet number 2, problem number 5, and so on. All right, so I think that's all I want to go over. With all that being said, let's go ahead and take a look at this first problem we have here. So for this one, this is the problem that dealt with the triangle where you basically know the measure of one angle. So we've got, x, y, and z, and we know that one of the angles is 32 degrees. The other two we don't know. We do know that x is bigger than y, and also that y is bigger than z, so these are both bigger than 32. That's all we know. And it says, which of these expressions is not sufficient, keyword being not, to identify the measures of all three angles in the triangle. Okay, so basically what happens with this problem is you first think about it and say, okay, x plus y plus z equals 180. All three angles in the triangle add up to 180. All right, but we know that z is equal to 32 degrees. So really you have this equation, right? X plus y plus 32 equals 180. Now, what ends up happening is if you look at all these answers, okay, all of these answers are going to be equal to some number. Now, we don't know what that number is, so I'm just going to use a generic C for it. And basically, if you set them all up, so I'm just going to, in kind of like the same format here, so I'm going to put the 32s all under the 32, even though they're listed first, and then line up like the x and the y terms. So I'm just going to switch the terms, basically. This. And then for answer choice C, we've got 3x minus 3y. And then for answer choice C, we've got x minus 3y. Okay. Plus, plus. And then these would just be equal to some number. I'm just going to, whatever, call it C for right now. Some constant. Basically, the way to look at this is you have a system of equations. You have this first equation, or this first condition, which is that all three angles have to add up to 180 degrees. Then the answer choices are a second condition, or basically form a second equation, which is that each of these expressions is equal to some value or some number. So essentially, to solve this, you would take the system of equations, meaning the top equation here, and then combine that with each answer choice, and essentially see, can you solve for the value of x or y doing that? For one of them, you cannot. For the others, other three, you can. So if you don't recognize it already, the answer for the one that is not sufficient is going to be letter B here. It's going to be this one. And the reason is because if you take the original equation and you multiply everything by 3, okay? So 3, 3, 96, 540, and then you add it to this one. Notice what happens is 3x minus 3x cancels out. The x's are gone. 3y minus 3y cancel out. The y's are gone. So all you end up with is basically 96 plus 32, whatever that is, 128 equals 540 plus whatever value the angles were given in, whatever value be told. And notice that there's no solution here, right? So essentially, excuse me, what's going on here is this equation does not, this system of equations does not have a solution. Therefore, you cannot determine with specificity the exact values of x or y. Every other possibility, basically A, C, and D, you could. If you went ahead and multiplied by 3, and then if you add these two together, you'll notice the y's will cancel out, but the x's won't. And therefore, you could go ahead and you could solve for x. You can get a specific value for x. And then if you did the same thing with this one and this one right here, again, you multiply the top one by 3, and notice now the y's are going to cancel out. 3y minus 3y, and again, you could go ahead and add them and solve for x. And then you do the same thing with the last one, and again, notice the y's are going to cancel out, the original and answer choice D, so then you could go ahead and solve for x. So the correct answer to this one is going to be letter B. Now, just to show you real quick in Desmos visually, how this works, or essentially why this works. So you take the original equation, which is the x plus y plus 32 equals 180. Or, whatever number you had for the measure of z. That part is essentially irrelevant. Okay. So there is that equation. Now we go through the various answer choices, and what you have to do is you just have to pick some random number to set them equal to. Now, through testing, I determined that if I picked numbers like negative 300 and positive 300, then they would work out nicely such that you get values for the intersection points that make sense, meaning that they are, less than 180 degrees. In other words, if you set this number equal to this, down here you get an intersection point that has a negative value, which you cannot have for angle measures. Technically you can have them for angle measures if you're talking about unit circle stuff, but you can't have them for angles in a triangle. Okay? So if you do something like this, notice, yes, we can determine, this is for answer choice A, by the way, we can determine the specific values for x and y. Now, technically, this would not be an acceptable answer because the x value is not greater than the y value. So really, maybe if I do something like this, okay, here, now it works. Now I have an x which is greater than y, and all three of them together add up to 180, and so A is not the answer, okay? Now, if you go through B, what you're going to see is the two lines are parallel, meaning you cannot find what x has to be and what y has to be. And it doesn't matter what value you choose on the right. So if I just go ahead and slide this, notice it's not really moving very much. I have to basically bump it up here to much larger values. Notice here it's getting further away, or if I go the other direction, it's getting closer together. But they are never going to intersect. They are going to be parallel. Right? No matter how large I make it, they will never intersect. Therefore, the value of expression B is not sufficient to identify the specific measures of x and y. And we can do the same thing with answer choice C. So like here, let's just slide it right here. Okay, 87 and 61, x is greater than y. Okay, that works. And then let's check answer choice D. Okay, here, 130.5, 17.5 doesn't work because the value of y is not greater than 32. So I got to slide this down a little bit. Let's go here. 97.25, 50.75, x is larger than y and y is larger than z. Okay, this works. We found x and y. It's not the answer. Okay, so that's just a little visual representation of how you could solve this problem in Desmos. All right, let's look at the second question now, the one with the colony of bees. So when you read through this question, it seems like a very complicated and complex question, but it actually is not that difficult, and I'll show you. Here is the way you can solve it. Basically, what's happening, to find the total number of bees after some number of weeks, whatever W is, right? You would say, okay, we start with 1,900 bees. The first 2 weeks, we have 90 bees per week. So we're adding 180 total bees. Then we're adding 135 bees per week. Now, it's not going to be multiplied by W because this doesn't happen until week number 3. So that means it's technically multiplied by W minus 2. Because, for example, if you wanted to find the number of bees after, say, 3 weeks, right, it would be 1900 start plus 180, first 2 weeks. And then for week 3, you would just add 135, right? Because there's only one more week to reach 3 total. That's why it has to be 3 minus 2, because 3 minus 2 would be 1, and then 1 times 135 would be 135. So this overall expression represents the total number of bees after W weeks. So now you go ahead and you basically, this is 180, this becomes 135W minus 270. You combine this all together, 1900 plus 180 minus 270, it becomes 1810 plus 135W. So again, that is the total number of bees that you have. But this question wants to know how many are there remaining to reach the goal of 3050. So all we're going to do is subtract, like 3050 minus the number of bees we currently have. That will tell us how much is left or how much is remaining. Or really think about it like number of bees that you have is this, and then you're just going to say you add x, that's the number of bees like remaining or needed. And then together those would equal the 3050. That's your goal. So if you rearrange this, subtract this whole thing to the other side, that's where I get the 3050 minus that expression. So 3050 minus 1810. If you go ahead and subtract that, it should be 1240 and then minus 135W. Let's just go to Desmos to confirm that all the calculations are correct. So let's get rid of this 1900 plus 180 minus 270. So first we have 1810. Okay, good. And then let's just put a giant parenthesis around that, 3050 minus that. Okay, 1240, and then obviously the 135W flips. So the correct answer here is going to be letter D. Now, you could also solve this using back solving. So let's go back to the example I was doing earlier where I said, okay, after 3 weeks, this is the number of bees I would expect. And I'm just going to do this on Desmos because it's going to be so much quicker. So we would expect there to be 1900 plus 90 week 1, 90 week 2, 135 week 3. So after 3 weeks, we have 2215 bees. If we need to reach the goal of 3050, how many more bees do we need? Well, 3050 minus that 22 whatever, just put it in a giant parenthesis, 835. So I'm going to go to the answer choices and I'm going to plug in W equals 3. And I'm going to see Wait, why am I doing this? I don't need to do this. I can just do f of 3. There we go. And I'm looking for the answer that gives me 835. Okay, so first one, not correct. What am I doing? I forgot to type the W there. There we go. 1900 minus 135W. That's what I want. I plug in 3. Not correct. Now let's check in the second. Let's check the second one. 1810 plus 135W. 2215. Not correct. Again, we're looking for 835. What about if I flip this? 1405. Still not correct. All right, let's check D. 1240 minus 135W. What do I get when I plug 3 in? Right here, 835. That matches the number of B's that I would expect based on doing the calculation manually without a formula. Therefore, using back solving, I have shown that the correct answer is the letter D. All right, let's look at question 3 now. At the bottom, here we have a rational function with a quadratic on top and also a quadratic, but it's already factored on the bottom. We're given 2 points. What is a possible value of q if f of q equals 0? So we already technically know one of them right here is 10. The question is, what's the other one, right? So if you want to do this one by hand, what I would do is I would take these points and plug them in. So let's start with the 0, 5 halves. So I'd say, okay, 5 halves equals 0 minus b times 0 plus c over 0 plus 4 is 4, and 0 plus 17 is 17. All right, so these are all going to drop out. This is just 68. So we're going to multiply this. Let me just look at my notes here. So c is going to equal 68 times 5 divided by 2, or I think it's also equal to 34 times 5. And of course, I will show the Desmos, there it is, 170, the full Desmos solution to this afterwards. All right, so we know c is 170. So now what you would do is we'd plug in the other point. 0 equals 14 times 10 plus 7, 17. So we're plugging in 10 for x. The bottom really actually doesn't matter, though, because when you go to multiply the top, it's just still going to stay 0 when you cross multiply. We got 10 squared minus b times 10. Now we can fill in the 170. So 14 times 17, again, if you multiply by this on both sides to cancel it out, the left side still stays 0. So basically everything, just drops out, and really you get this. And now we have 0 equals 100 minus 10b plus 170. 270. 0 equals negative 10b plus 270. Of course, you can go to Desmos and do this. You do not need to do this by hand, but I'll just go ahead and finish it here. I get b equals 27. Let's check my notes. Yes, that is correct. So now you could just basically go to Desmos and graph it, or really what you could also do is basically plug in the values and just factor this. I mean, it's basically going to factor as x minus 10, x minus 17, x squared minus 27x plus 170. So, okay, the 10 is already in the problem. What's the other possible value? Well, it's right here, x equals 17. So it's letter D. Now, let's see how you can do this entire problem in Desmos. So let's delete this. Let's make a table. Let's put our 2 points in the table. Let us do regression of this rational function with the exact form that it's given in. Okay, so notice it gave me the b and c values that I was just solving for. So, okay, this is one x-intercept. The problem is it's a little tricky to see, but like basically look, notice it's not going to be a or b. Okay, it doesn't cross the x-axis over here in the negative. So we're down to c or d essentially. And I mean, it's probably not going to be c because like right around here, notice around 7, it's not at 0. If you click on it, you can find the other one is right here at 17. Or a little trick you can do, if you have a rational function and the top, for example, is a quadratic and you're trying to find another 0, just graph the top part. And I can just use B and C. It'll carry those values over. Just graph the top part, and now it's so much easier to see. Oh, it's right here at 10. It's here at 17. So that's a little trick you can use if you have a rational function and you're trying to find an x-intercept or a 0, but it's like real flat or it's difficult to see, and the top is, say, like a quadratic. Just graph that numerator from the rational function. All right, let's move to the top of the next page. Question number 4. So here you have the polygon that has 30 total sides. There are n sides of 6 centimeters, 12 sides of 2 centimeters, 4 times as many sides with 5 centimeters as there are with 6, which shows the number of sides. Okay, so we're just adding up the sides here. So we've basically got n that are 6 centimeters. We've got 12, which are 2 centimeters, and we have 5 centimeter sides, but there are 4 times as many as there are with 6. So that means there are 4 times n. So we just add these up, n plus 4n, 5n, plus 12. That equals 30. That's the answer. Letter B is correct. Pretty much the only way to solve this problem. Note that for D, okay, this right here, these are not the number of sides. This is technically the perimeter of the polygon, okay? But it's not asking for what an expression for the perimeter, and it doesn't give you the perimeter. It's only asking for total sides. So this expression in D is technically, again, this is if you were to calculate the perimeter of the polygon. Next, let's look at number 5. Here you are given an equation, has a linear equation, has a constant in it, and you're told that there is exactly one solution. Basically what that means is it's not no solution and it's not infinite solutions. And what cannot be the value of A? So if you multiply out the left side, you get 5a minus ax equals 40 minus 8x. Well, for there to be a solution, the x's cannot cancel out. That means the x terms cannot be the same because they're on opposite sides of the equal sign. Therefore, a cannot equal 8. If a was equal to 8, then technically you would have infinite solutions because you would have 40 minus 8x equals 40 minus 8x. It's all real numbers. Or I guess also, you could say also as infinite solutions. So the correct answer for this one is going to be letter C. You could also basically check this by graphing if you wanted to. Essentially, it's like graph y equals 40 minus 8x. Y equals left side, y equals right side. Then you could add a slider. Start at 1. Notice here, like, if you go this way, essentially it's going the wrong direction. It's not going to, essentially, it's not going to overlap. And they're also, notice because right here, like, there's the same x-intercept on both, they're never going to be parallel. So it's really the infinite solution case is the one that you're concerned with. And you can basically see now it's a little tricky because you got to zoom in a little bit here, but notice, right when they get to 8, it overlaps completely. But really, this is a problem that you should know the theory behind and should be able to solve, using the the theoretical approach, knowing that the x terms, for there to be one solution, the x terms cannot be the same, and therefore a cannot equal 8. All right, let's look at question number 6. Here you have two similar triangles, ABC and DEF, and you're told each side of ABC is 4 times the corresponding side of DEF, so ABC is larger, DEF is smaller. You're also told AB is 40, BC is 20. Okay, the length of DE is A centimeters, EF is B centimeters. What's the value of A plus B? So A is 4 times, excuse me, the corresponding side length. ABC is the corresponding side length in the smaller triangle, so that's our scale factor. So basically, A times 4 is equal to 40. Or in other words, A is going to equal 10. And similarly, B times 4 will equal 20. So B is just going to equal 5. So a plus b is 10 plus 5, which in this case would be 15. And that's it. Nothing else to do for this problem. All right, let's look at question number 7. Okay, so for this problem, you have a system of equations, but basically they're telling you that the solution point is really the x-coordinate is some number divided by 9 and the y-coordinate is some other number divided by 9. They want to know what are the values of those two numbers. So all we have to do is go to Desmos, and we can just graph this. Now I will show you how to solve this by using regression just after this. Okay, so we get this, right? The problem is, if you type in exactly, actually let me do this. Let me duplicate this so I have 2 entries. Okay, so just for the x's, if I do this, notice it doesn't give me the correct fraction, right? It's not something over 9. And the same thing's going to be true with the y's as well. Sorry, the y-coordinate. Like, if I just take the approximated value from here, okay, this is not over 9. This is not the answer. We're not adding these two, values together. All right. So what you have to do, what you have to recognize here is, okay, it's a pattern of repeating 2's. You have to just type and add some more 2's, and then it will give you the correct fraction. Same thing with this. So now, what is P? What is Q? Well, P is just going to equal 20. Q is going to equal 10. So we go ahead, we add them together, and we get 30. And that's the correct answer. That's what you would fill in. Now, once you got the fractions, of course, you could just, if you needed to, you could just do like, excuse me, this number right here, use regression is equal to p over 9, and then it just solves it and gives you 20. Or same thing like right here, you do this, q over 9, not over p, q over 9, and you get 10, and then you could just add them together, p plus q. Scroll up, there you get 30. All right, now, however, here's the way you can avoid having to type out the extra decimal space and everything. We can solve this using regression. So we're going to put the first equation left side, comma, second equation left side, first equation right side, comma, second equation right side. All right, notice it gives me the same exact answers. The difference, or the problem, is, or not the problem, but the benefit to using regression is now if I do that same thing, all right, x1 equals, oh, it's going to be, shoot, we're not going to be able to do regression because we're going to have to store it. Sorry, this is what we want to do. We don't want to we can't set it equal to p. We can't use that technique. Instead, now we can just type it. Because it has all the extra decimals stored, if I just click this, it's already in the correct answer. Okay? So you can clearly see here it's 20 over 9, so p is 20. Same thing with y1. It has the extra decimals. It's 10 over 9. It has the exact value. 20 plus 10 answers 30. So that's the advantage to using regression for this one. All right, next question, number 8. Here we have a quadratic equation. You are told one of the solutions is of the form m plus root n over 3. Find the value of m plus n. Okay, I am going to just first quickly show you how you could do this by hand if you wanted to. Then I will show you how to do this very quickly and easily in Desmos. So, by hand, of course, you're going to do quadratic formula. We got our a, we've got our b, we've got our c. So we're going to do negative 18 plus or minus square root 18 squared minus 4 times 3 times negative 26 all over 2 times 3. 6, negative 18. I'll just tell you because I already did it in Desmos, but I'll check it. The square root number should be 636. 636 divides by 4, and it turns into 159. 4 times 159. So the square root of 4 comes outside as a 2, and then we have a 6. Then you divide the 6 into both terms. Negative 18 over 6 is negative 3, plus or minus root 159. 2 over 6 becomes 1 over 3. Okay, notice here's m, here is n. Negative 3 plus 159 is m plus n. The correct answer to this is 156. Okay. So that's, if you want to do it by hand, that's how you could do it. Now, let's look at, and again, I save time here, obviously, because to do this calculation, you'd have to go to Desmos or punch it in on a physical calculator, right? So it's not quite as fast as I showed there. Let's say you could do this in Desmos. What I'm going to do is I am going to first type in the function. And by the way, the technique that you have to use on this, because there's two constants in the answer, this is in my Ultimate Desmos Guide to Digital SAT Math, specifically the section, the video that focuses on quadratics. It's in a separate, like 25, 30-minute video that goes through some of the techniques of solving quadratics and like finding no real solution, one real solution, two real solutions, and those kind of things. So the thumbnail will be on the screen to show you which specific video that is. All right. Now, there's two ways we can do this here. The way that I personally prefer, which is actually more typing though, is to do a system of equations, and we're going to put in f of, and I'm going to first type in the given solution, which is m plus root n over 3. However, I have to use its conjugate, m minus square root n. Do this, it'll be quicker to do it this way, over 3. Okay? And now I'm going to set up a system of equations because I know that both of those are equal to 0 in the function. All right, so what is happening here? I've got f of x. Oh, I typed x1s here. Why did I type x1s? This is not regression. You don't need to type x1s because of that. That's the whole problem. There we go. So notice, it gives me m, it gives me n. M plus n, 156, that's your answer. You know, it takes maybe 30 seconds, possibly 45 seconds, especially if you don't make a dumb typo like I did. Alternate way you could do it, which is quicker, you could also do this. You could put an x1 here, and then you could type x1 equals, and you make a list, and you put both of the solutions in the list. And put the fraction sign first, and over 3. Okay, wait, no, hold on. Let me just double check. Maybe we don't want the, maybe we don't, no. X1 equals, okay, why is it giving me, oh, okay, never mind. Just remember, this is how we have to do it. We have to take the function, we actually have to do regression here using this method. You have to take the function, you have to regress it to 0, and then x1 down here is a list, an element list, and in that list are the two different solutions, the given solution and its conjugate. There we go. So this is the approach you have to take if you want to enter it in this form. It's a little bit different than the other form where I just entered it as a function and did a system of equations. This is technically a regression statement and then an element list where the element list has the two solutions. But it's still, notice it gives us m plus n. Correct values right here, m plus n, 156. So this is an alternate way to type it in or to approach it if you want. I prefer the first method, but either way is technically fine. All right, here is the last question on November 2025 worksheet video number 1, problem number 9. So what I'm going to do, this one is just show you how to do it by hand as quickly as possible. Then I'll show you the Desmos solution that can solve it for you. Basically, you're given two polynomials and you're told what their product is, and they want to know what, and basically one of them has a constant in it, want to know what's the value of this constant. So in other words, 8 times x minus 2 times x cubed plus nx squared plus 2nx plus 8 is equal to 8 times x to the fourth, okay, minus 16. So basically, if you're going to do this by hand, the easiest way to do it is notice the right side basically becomes a difference of squares. X squared minus 4, x squared plus 4. Then the right side, then x squared minus 4 is a difference of squares again. X plus 2, x minus 2, and times x squared plus 4. Okay? So on the left side, we have 8 times x minus 2 times x cubed plus nx squared plus 2nx plus 8. All right, so notice what we have here. This and this match. Okay, this and this match. So that means that this thing must be equal to this times this. So basically, just take these two, multiply them out using FOIL. So first, x times x squared, x cubed. Outer, x times 4, 4x. You can actually stop here and get the, I mean, I'll do the whole FOIL, but for solving the problem purposes, you don't need to continue further. Inner, 2 times x squared, 2x squared. I'm actually going to write that next, just to put them in descending order. 4x, and then last, 2 times 4 is 8. So now, match up this to this parenthesis right here. 2x squared, nx squared. Well, the n has to equal 2. Same thing, 2nx right here. The 2n must equal 4. Well, 2n equals 4, n equals 2. So the correct answer is just positive 2. But now let's see how you could do this entirely in Desmos. So I'm just going to take the two expressions, use regression to equate the product of them, x cubed plus nx1 squared plus 2nx1 plus 8 tilde, and now we know what it's equal to, which is 8x1 to the fourth minus 16. Okay, notice it's already giving me n equals 2. Now technically you should add an element list for x1 because you don't want that to return a value. So I'm just going to do negative 2, 0, 2, 3, 4. I mean, it's giving me 2 even like when I put in two numbers, but whatever. I'll just put in a couple here. So notice right here, the answer is 2. That's it. Nothing more you need to do. It takes you under 30 seconds, assuming you can type everything correctly. All right, so those were the 9 problems on this first November 2025 Digital SAT Math official test problem worksheet. If you did like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, check out worksheet and video number 2 once that is posted. And also check out worksheet video number 3, the one that'll highlight just briefly all of the repeat problems that appeared on this November exam that have been covered previously. If you have any questions or comments or alternate solution methods, please leave them in the comments section of the video below. Otherwise, last thing I just want to mention, if you are looking to learn Desmos to help improve your digital SAT math score, please check out my Ultimate Desmos Guide to Digital SAT Math. It is up to over 5.5 hours of tips and tricks and instruction and 65 practice problems, plus some other practice problems that I go over in some of the other videos that aren't part of the main worksheet to help you ace the digital SAT math section using Desmos.